we are going to talk about data locations in Solidity. The different data locations are storage, transient storage, memory, stack, and at last Calldata. Storage is the first data area which is persistent between function calls and transactions. All state variables are stored in storage. It is permanent. Second data area is called transient storage. It is reset at the end of each transaction. When a transaction starts, at the end of that transaction, the transient storage is reset. The third data area is called as memory. It is being used by the contract to perform operations during runtime. Ethereum Virtual Machine is a stack-based machine. Hence, all operations are done via the stack. And at last, we have Calldata, which is used to send function arguments. Mostly, all external function arguments are sent as Calldata. Now let us take a look. Let us take a look at the data locations example via a simple smart contract. In this smart contract, we have created data locations. These are the state variables: array, map, and structure. Now these variables are stored in storage area, that is, it is permanent. Secondly, here we look at loading the state variables into different memory locations. Here my structs is loaded into storage, and here my struct is loaded into memory. So these are the different locations in which we can load the state variables. When we load the state variable into storage, updating the state variable will also update directly the value in the storage. Whereas if the state variable is loaded into memory, updating it will not update it directly into the storage. So this is the difference between loading a state variable into storage or loading a state variable into memory. Here we have function f in which we are passing array, map, and my structure. Have a close look at the memory locations. In all the three cases is storage. That means any update to these values will also update their values directly at the global storage level or at the state variable level. This function f internally calls _f and it passes on these state variables, that is ARR, which is defined here. Then secondly, it passes on map. Thirdly, it passes on my structs. Now scrolling down, inside the internal function f, what we do, we are iterating a for loop, or that for loop goes from I equal to 0 to less than 10. That means it will go from 0 to 9. And what we are doing is, we are pushing I into the array, or we are pushing I into this state variable, because this state variable ARR was being passed from function f at this location. So ARR, map, and my structs, these are nothing but our state variables which are being passed on to the internal function f, and they are loaded directly into storage, which means any update to these values will also update their value directly into the storage of the smart contract. So what we do, we are assigning the value of I, or we are pushing the value of I into array. Then we set the map of I to address 1, and at last we use unchecked for incrementing I, which is gas efficient. Once this for loop exists, we set the value for my struct.foo to 100. We will verify this when we will deploy and run the transaction. How can you return the memory variables? This is one way. Since our array state variable, its visibility is internal. In order to return that array, what we have done, we have created a function g, public view returns. It returns an array of unsigned integer 256 and returns that array via memory. Here we are just added a return statement, return ARR. And at last we take a look at the Calldata part. In the Calldata part, what we are doing is, we are again iterating over the array length, and the my structs of I.foo, we assign whatever the value that we are passing inside this ARR Calldata array. And at last, again, since unchecked is gas efficient, so we are using I incrementing I inside unchecked. So this is all about different data locations in Solidity. First we have is the storage, which is persistent across function calls and each transaction. Then we have memory, which the smart contract uses to perform operations during runtime. Then we have Calldata, which is used for external functions to pass function arguments. Now let us deploy this contract and interact with the different functions. Going to the Solidity compiler option, click on compile DataLocations.sol. Once you click on it, it shows compile DataLocations.sol. Let me click over here, compiling. It is compiled. After compiling, go to deploy and run transactions. When I go to deploy and run transactions, this smart contract will be deployed on the Remix virtual machine via account 1. So these are test accounts. It has default 100 Ether ballots. Since the contract is already compiled, I'll directly click on deploy. Once I click on deploy, I can verify from the Remix terminal that the contract has been deployed. After deploying, let us now interact with the contract. Click on data locations, select a function to interact with. So I am selecting function f. Now remember, from within function f, we are calling internal function f, which updates all the 3 different state variables. So let me call that. On clicking transact, I can confirm from the Remix terminal that the function f has executed successfully. Now let us check the after effects of function f. This should have pushed the value of I starting from 0 to 9 inside the state variable array, and it should have set map of I equal to address of 1. That is, map of 0 to 9 will be equal to address 1, and at last it should have set my structs of 1.foo equal to 100. Why my structs of 1.foo? Because here we are passing my structs of 1. Let us check that. Again, click on select a function to interact with. Here I'll select G, because G is the function which is returning the state variable array. Clicking on G, click on call, here it is. So our state variable array has been updated successfully with the values 0 to 9. Now let us check the map value. Map of 1. Here we have map passing in the parameter 1. Click on call. So it returns address of 1. Similarly, now let us check the my structs of 1. Clicking on my structs, passing in the parameter 1, it should be 100. Here it is. We have set this to 100. So these are the different data locations in Solidity. First, we understand what data locations are. Then we have did a small, practical example considering the contract data locations and have gone through the data location storage, the data location memory, the data location Calldata. If you have learned something valuable, please like, share and subscribe. This encourages us to create more content going